Like previous workshop, we have participants from all the parts of the country, and more than 100 participants have already joined. It shows how vibrant INSPIRA Research Association is. In fact, we all are facing a very severe crisis of pandemic 19. But I am really touched and very happy to see that INSPIRA Research Association since last March have already organized more than 16 programs, and most of the programs have received an overwhelming response. Most of the programs have been organized on research methodology and related areas. Apart from that, this association has organized few programs on soft skills also, like team building, interpersonal relations, etc. So this association is really doing extremely good work for the benefit of young budding researchers. And today's workshop is another important dimension in which we will be listening to two very eminently. As you all know, that multivariate analysis is conceptualized by tradition as the statistical study of experiments in which multiple measurements are made on each experimental unit, and for which the relationship among multivariate measurements and their structure are important to the experiments understanding. There are many models, each with its own type of analysis will affects the other, and finally, what affects the variable will have on the final outcome. In fact, today's session will be mainly conducted by Dr. DHAVAL MAHETA. Dr. MAHETA is in this particular topic. He is currently professor in the Department of Business and Industrial Management in South Gujarat University, Surat. He is BE Production, MBA Finance, NET in Management, and PhD in Management, along with postgraduate diploma in research methodology. He has 17 years of postgraduate teaching experience. He has presented and published more than 30 research papers in national and international conference. He has been the key resource person for the research methodology workshop organized at various levels, including NITs in the different parts of the country. He has published books on data analysis using MINTAB, statistical analysis using R, machine learning using RRETL, etc. He has organized various faculty development program on data analysis using SPSS, AMOS, Multitab, and Stata, etc. So he is having a very vast experience in conducting such workshop, and I'm quite sure that all the participants will be immensely benefited by his expertise in this field. The other resource person, Dr. HITESH PARMAR, is currently working as postgraduate department of business management there as a professor in Sardar Patel University, Vidyanagar, Gujarat. And he is also having that engineering background along with MBA in operations management and marketing management. He is also PhD in management and postgraduate diploma in research methodology, academic and research experience of more than 14 years. He has successfully conducted more than 90 faculty development programs and workshops in the field of data analysis, and he is well versed with various statistical tools and software in the field of research methodology. In fact, he has already trained more than 5,000 participants. Uh, Again, he has a very vast experience of conducting such workshops throughout the country. He has also co-authored 3 books on business statistics, predictions and operations management, and research methodology. So I'm quite sure that with their vast experience and dealing with a wide variety of statistical tools and software, uh, our all the participants will be greatly benefited. My only expectations from the participants that throughout these 7 days, they will be actively participating in the deliberations, and they will be asking number of questions and hand over this forum to Dr. Mehta for further proceedings and deliberation. Dr. Mehta, please.
Thank you, sir. Thank you, Anil, sir. Yes, Professor Mehta, sir, please.
Yeah. Can I start?
Yes, sir. Yes, sir.
Let's have some testing. Okay, let's have some testing.
Yes, sir.
Is the screen visible?
Yes, sir. It's coming, sir. It's coming.
No, wait a minute.
Yeah, it's coming, sir.
Just a minute.
Yeah.
It is giving me some problem here. Okay, just
no problem, sir. No problem. No problem. Yes, sir. Now it's coming, sir.
Yeah, it's visible, no?
Yeah, it's visible, sir. It's visible.
I request all of you that please close your videos, switch off your videos, because it takes a lot of bandwidth. Okay, Sumi madam, I request you to please turn off the video. It takes a lot of bandwidth. Okay, wait a minute. I will also okay. Am I audible? Am I visible? Shall I start?
Yes, sir. Yes, sir.
Okay.
Sir, you have turned off your camera. Okay.
Yeah.
Okay.
Camera is off. Camera is off.
Okay, sir. No problem.
It is because it takes a lot of bandwidth.
Yeah, sir. Yes, sir. No problem, sir. No problem.
Okay.
Okay, sir.
So these are okay. Wait. So before we enter into the regression analysis, I want to make you aware about the basics of hypothesis testing and what is research. Believe me, I will not be talking too much about the theory, but it is the key points which are necessary, like what is hypothesis, what is a null hypothesis, what is a p-value, what is the interpretation of p-value, and that these are all things which are necessary for a subsequent next 5 days. So I'll make you aware about all those things. So the development of any science depends upon the empirical research in that area. So we frame the hypothesis for this for the development of the science. Okay, so from where the term hypothesis emerged. So let us go back in the 1619 AD when Galileo gave the theory of heliocentrism. Please pay a lot of attention to me, because all these things, bits and parts, we will get connected at somewhere around you can say 7 or 7 p.m. All these bits and parts will get connected. Each and everything will get connected. Okay. Whatever which I am teaching on first slide, it will be we'll be trying to connect all those dots at 7 p.m. So please pay attention. So in 1619 AD, Galileo gave the theory of heliocentrism. According to this theory, the sun is stationary and Earth rotates around it. This is a new theory which was proposed by Galileo. But what happened was, what would have been the story that time? But the heresy had a different opinion. Heresy means traditional belief had a very different opinion. According to the old theories, Earth is stationary and sun moves around it. It was an old belief. The result was that the Galileo was prosecuted in 1633 AD for opposing the heresy. Just can you imagine that when you are giving any new theory, you have to be you are punished for that. So thanks to the progressive thinking which emerged in 19th century in Europe, in which they said that if you are having any empirical evidences for any empirical evidences for any phenomena, then please give the empirical evidences and your knowledge will be accepted in the society. So thanks that now a pathway was made for the researchers that they can put forward that ideas. Okay, they can put forward their ideas. We all know for many years we used to think that solar eclipse is having some stigma, but thanks to again the science development of the science, that because of them we are able to see the solar eclipse and we are able to understand what is a phenomena which is going on. So that's a progressive thinking. So the society progresses. I will give you another example to this progressive thinking, that during in 18 you can say 18 sorry 19 18 and 19th century, midway in between, the sati system, that is which was prevalent in females, the sati system, which was prevalent during the British rule, was considered to be a very good thing, yes, good thing, believe me, that if the females sacrifice their life for the males after their death, it was considered to be the good thing during those time. But thanks to this modern modern you can say the father of the modern India, Raja Ram Mohan Roy, he strictly opposed this. He strictly opposed this, that it is totally inhuman how we can do this thing. And because of the opposition, because of his opposition, a law was passed and the sati system was abolished. So what the thing is, the progressive thinking emerged, and because of this, the society progressed towards the good thing. So as a role of the your as your role being a researcher, you should come out with the good things which are happening, or what are the things which are happening in the society. You have to highlight that thing, and you have to present the empirical evidences for all these things, right? This means that the old belief could be challenged if enough empirical evidences are provided. But we all know that there are some societies which have a very regressive thinking, and people are not allowed to change the old beliefs. Now, uh, Karl Popper came out with the concept of hypothesis. Okay, and why this hypothesis is necessary in regression analysis or in parametric test, in non-parametric test, how to frame this hypothesis. Many researchers are facing this problem, right? So Karl Popper observed during there were two types of research which were very significantly happening during the time of the Karl Popper. The one of the research was of Sigmund Freud, and another research was done by the Einstein. They were all contemporaries, right? Am I audible, Ravi sir? Ravi
Yes,
sir?
sir. Yes, sir. Yes, sir. Bilkul. No
Okay.
problem, sir. No problem.
Okay. So Karl Popper observation on Freud was that he can prove anything. He can prove anything means why a person hugs too much. That is why a person is he's so much shy. Why he's so much happy. His theories can prove anything. Okay. Uh, just a minute. His theory could take any data points and data structure. For example, why a person hugs too much, or why a person does not hug. What was his observation on Einstein? So his observation on Einstein was that his theories, the theories of Einstein's were not looking backward, it were looking forward. Okay, he was looking ahead and predicting future state of affairs. So his theories could take only future data points. The theories of Sigmund Freud take the would consider the past data points. Okay, so Karl Popper considered Einstein's theory to be risky. Yes, it's considered to be risky, as if future did not meet with the prediction, the whole theory goes for a toss. Thanks to the solar eclipse of 1990, because of which the Einstein theory of relativity was proved correct. Now, what according to the Karl Popper was science? According to Karl Popper, both Einstein and Freud were dealing with different types of science. So the traditional thinking about science was to look at the world and develop hypotheses based on the observation. He said this is not the science. So according to him, what was science? In his words, what he has written, the original words of Karl Popper. According to the Popper, you observe first swan, it is white. You observe second swan, it is white. You observe third swan, it is white. And you draw conclusions that all swans are white. This was Sigmund Freud theory. It was based on human behavior and human phenomena. Okay, you collect the data and you interpret that thing. So according to Karl Popper, this is not science. So the theories of Sigmund Freud can be used to prove or disprove anything. So what is science according to them? So Karl Popper argued that instead of white swans, you start looking around black swans to disprove the theory, and that is the reason our null hypothesis is null and void. Okay, this is the basic philosophy of why our null hypothesis is null and void. So that is science. Now, what do I mean by science? We will again try to understand it in little deeper. Science disconfirms, pseudoscience confirms. Now, pseudoscience does not have any, you can say at that time the pseudoscience was written, but now this pseudoscience is known under the name of social science. Okay, but in that also we are not confirming, we are disconfirming only. So science is about falsification. Science is not confirm. If I confirm to your theory, then it is not science. For example, there were enough laws of gravity given by Newton. Okay, Newton gave the laws of gravity, but Einstein refuted that theory, that the theory that the laws of gravity which are applicable on the earth are not applicable in the universe. So he gave a total different theory. So here you can say that what is the thing is, it is a healthy refutation that I don't accept your theory. It does not mean that I am your enemy, but what I am saying is I don't accept your theory, I am coming out with a new theory. So that is the way. If one researcher has developed some model, the another researcher is giving the another model that I don't accept your model. It does not mean that I'm trying to disprove or I'm trying to negate the person. I'm just trying to give some more addition to the existing body of the knowledge. And why we are doing that thing? We are doing that thing so that our knowledge progresses, and because of this we are doing this way. So the swans can be black also. So what is the role of the researcher? The role of the researcher is now let the belief go and accept the evidences. Theory, your whatever theory which you propose should be testable, refutable, and falsifiable. Testable in the sense that if I'm saying that after death you will get the heaven, can I test that thing? No, I cannot test that thing. So that's not the theory. It should be refutable. You should be in the position to refute it. It should be falsifiable. I can falsify your theory, but that theory is considered to be good theory. Okay, so now the role of the what is now hypothesis and research. So the first step in research is framing a hypothesis. I will not talk the theory. I will not be speaking about anything about the theory. Okay, I'll try to make you understand each and everything from the practical point of view. A hypothesis is a tentative statement. We all know that. Fine. Hypothesis in act in statistics where we have analysts test an assumption regarding a population parameter. Okay, we understood that thing, but how to frame the hypothesis? Let's come to this. So there are three types of hypothesis. The first is a research hypothesis. For example, consuming coffee has effect on sleep hours. This is research hypothesis. You can say the researcher, it's also known as a researcher's hunch, a thinking of the researcher that this could be the possibility. Here could be written here. Now you will have to convert this research hypothesis into the statistical hypothesis. So the in statistical hypothesis, the first thing is now which is there is you make this thing as null. So there is no significant effect of consumption of coffee on sleep hours. Remember Galileo and Karl Popper. Okay, we test null hypothesis. Okay, we test the null hypothesis means X does not affect Y. There is no significant difference between X and Y. If you are having empirical evidences, give the empirical evidences and we will accept your knowledge. That is progressive thinking, the second slide. That is the progressive thinking. If you are having any proof of your theory, of your you can say phenomena or experiment, please give the proof. If the evidences are accepted, then we will go ahead. Okay, what is the alternative hypothesis? The alternative hypothesis is there is a significant effect of consumption of coffee on sleep hours. Then there is something which is known as a substantial hypothesis. This both are mutually exclusive event. The third type of hypothesis is a substantial hypothesis. This part, this PPT, you can say this particular slide is, I have taken it from the Ken Black. Ken Black is considered to be the best book for understanding the hypothesis. Okay, now the words are reserved for the hypothesis and the testing, because if you write there is no significant difference, then you will be using some another thing. If you are writing there is no significant association, I'll be talking discussing all these things. There is no significant association, you will be doing different thing. There is no significant linkage, you will be doing different thing. Okay, so the depending upon the hypothesis and depending upon how many variables are involved, normally we get confused that sir which test we should apply. We will solve all your queries. Okay, so what is the substantial hypothesis? Substantial hypothesis is that sometimes the statistics may say that there is no significant difference, but the researcher may feel that the difference is there. For example, it was found in the process that 1 gram of the product is going more. Okay, the producer is selling some product in the market and it was found that 1 gram of product is going more. 1 gram of product is going more to the consumer. So if you test according to the according to the statistics, it will say that there is no significant 1 gram is not so significant and we should not worry about it, because according to the statistics 1 gram is nothing. But so if 1 gram is cotton, fine, no problem. But if 1 gram is gold, lot of problem can happen. So the statistics cannot understand what variables are involved. What is the variable? It will not understand. It will use the same yardstick for each and every product. So here the researcher should understand that this is gold and this is cotton, and then it should give the judgment. So that's a substantial hypothesis. Okay, so what are the statistical tools which we normally use? The statistical tools are used to do the empirical testing of the hypothesis. Now, which tools depends upon what are the levels of measurement of the variables which are involved in our study. So normally there are 4 types of variable. All of you please write down on one page, because we will be using this variable quite often. Okay, to understand this thing, you will be provided the recording also. So there are 4 categories or 4 levels of measurement of the variable. So one is nominal, ordinal, interval, and ratio. Normally we get confused. It is very normal that we get confused. But what is the ratio? A ratio has got a true zero. Interval does not have a true zero. Don't get confused. Okay, I'm repeating again. I'll give you a layman example. We have collected a layman example for each and everything, so that you can understand this statistics, which is, you can say, a little bit dry subject in a very easy way. So the example of interval scale is time. When you see your clock in the night at 12 o'clock, the time shown on the clock is 00.00. So at that time, you don't say that there is no time. Okay, so there is a time, but this zero is not a true zero. For example, if the temperature is 0 degrees Celsius, you are not saying that there is no temperature. Okay, so when the zero does not mean a true zero, then it is an interval scale. And if the zero means true zero, then it is a ratio scale. Weight zero, height zero, it's a ratio scale. Now, for the good news for all of you is that the software does not differentiate between interval and ratio scale. Most of the software does not differentiate between interval and ratio scale. For SPSS or R or any of the software, the interval and ratio is having one common name, and that's a continuous scale or a scale variable. Now, the second category of the variable is the ordinal scale. If I say that a student has secured the first rank in the class, I'm repeating again. If I say that a student has secured a first rank in the class, okay, and the roll number of the student is 1, okay, there are two students. The first student has secured first rank in the class, and the second student, which is there, his roll number is 1. Now, which number is conveying some meaning? Naturally, the first rank is conveying the meaning. It is talking about the commitment of the student, dedication of the student, motivation of the students, right? For roll number 1 does not convey any meaning. Similarly, you must be watching the IPL. In IPL, there is something which is a jersey number, that he is wearing a jersey of 10. This does not convey any meaning, but the ICC rankings which are there of the players convey some meaning. So ICC rankings are the ordinal scale, and the jersey number is just a nominal number. Normally we get confused. So if any number is conveying the meaning, then we say it is a ordinal scale. The last category is pass or fail, yes or no, that way. I'll give you a very simple example to this is that, for example, the percentage of the students is a ratio scale. Percentage of a student is a ratio scale. I can convert this percentage of the students into the rank which a student has secured in the class. That's an ordinal scale. I can similarly convert that thing into pass and fail. So that's a nominal scale. Okay. So depending upon that thing, we are classifying that thing into parametric test and non-parametric test. Okay, so parametric test, from that I'm deriving a word parameter. Okay, parameter. Now, any variable whose parameter can be calculated. Now, what is a parameter? Any variable whose standard deviation and mean can be calculated, that is known as a on that variable we can apply the parametric test. Okay. Types of test. Parametric test is there, in which we are doing the normality testing. Yes, you will get confused what is normality testing. I'll be talking about that thing, because we will have to do the residual normality testing of residuals today. So that's a normality which we are talking about. Non-parametric tests are those tests in which we are assuming that the variable does not obey the normal distribution. Now, what is the normal distribution? Let's go ahead. So all those who are confused in the sense that, sir, when to use a parametric and when to use a non-parametric, I have made a keyword for you. See, this is nominal, this is ordinal, and this is ratio. Take the first two words, N, O, non-parametric. Take the R of this, it's a parametric. So now there is no confusion. So in case of nominal and ordinal, we are using non-parametric, and in case of ratio, we are using parametric. Now, why we are doing that thing? Because ratio, the example of ratio is weight and height. So it's a continuous, we can calculate the standard deviation and we can also calculate the mean of it. And as we can calculate the standard deviation and mean, so that's a parameter. And as the parameter is there, we can do the parametric test. Now, in case of nominal and ordinal, we cannot calculate the mean and standard deviation. I'll give you a very simple example. Let's suppose you have done the coding of male as 1 and female as 0. Can you calculate the standard deviation of 1 and 0 coding, or a mean of 1 and 0 coding? No, you cannot do it. And therefore, as you are not able to calculate the parameter, so you are using non-parametric test. Okay, so are you confused in framing the hypothesis? So what normally what we want to disprove is the null hypothesis. When we begin to test a theory, we are looking to confirm it or disconfirming. We are trying to disconfirm it. Okay, very recent example of pandemic, which you will be able to understand very easily. The statement which we want to prove is an alternative hypothesis, but don't have the affinity that we have to prove this. So our research starts by disproving the null hypothesis. First, write the alternative hypothesis. This is for your understanding. In your thesis or in your paper, you will never write the alternative hypothesis first. You will always write null hypothesis, but this is for your understanding. I am trying to give you the example. Okay, so the alternative hypothesis is mortality rate is high in old age patients affected by COVID-19. All swans are white. The null hypothesis will be there is no significant effect of age on mortality rate of COVID-19 patients. All swans are not white. So this is the concept. Whatever we want to prove, we write in alternate and then we frame the null. Okay, I'll give you another example to this, that normally in the court, suppose somebody is accused of crime. Somebody is accused of a crime. So the person is brought in the court, and there can be there are two ways in which the case can start against that particular person. The first way is that the person has not committed any crime. The first way is the person has not committed any crime and the evidences are given to prove him guilty. Okay, the evidences are given to prove him guilty. Is it clear? The second scenario can be that the person has committed a crime. Okay, it is assumed that the person has committed a crime and the evidences are given that the person is not guilty. Now, our Indian law has adopted the first method. The first method is what? That the person has not committed any crime. Please give the evidences that he has committed a crime. Okay. Now, why a second system is not advisable? Because in the absence of any evidence, the person will be default considered that he has committed the crime. Similarly, in research, suppose if we assume that the alternative hypothesis is true, then according to the Karl Popper, what would happen? There will be the piles of theory around the society, and the role of the researcher would be to negate that this theory is not good, this theory is not good, and there will be so much garbage of theories. And therefore, what his thinking was that no, we will start with the no premises, that there is no relationship between X and Y. If you are having any evidences, prove it. Okay, if he would have gone otherwise, that there is a relationship between X and Y, and now the role of the researcher would be to negate it, then it would be you can say there will be so many theories which will be there in the market. Okay, so this is the basic philosophy of the hypothesis. Now we take the sample from the population, and we want that the sample should be normally distributed. Normally we face a lot of problem that, sir, what is a normal distribution? I'll make your life very simple, that what is this normal distribution? I hope you can see this thing. Ravi sir, is it visible? Ravi sir?
Yes, sir. Yes, sir. It's visible.
Please don't mind, because I'll be asking these things quite often,
No,
because we are on internet,
no
and
problem, sir.
sometimes,
Yes, yes.
okay, yeah, fine. So now let's try to understand this thing. Now, what is a normal distribution curve? It's very simple thing, okay, but we make it complicated by using so many formulas and equations, which very simple thing. See, what is the probability that there is a very tall student in your class? What is the probability that there is a very tall student in your class? Okay, so it may be the tall student may be one or two only. Okay, so the probability is very low. And what is the probability that there is a very short student in your class? Very less. So both the probabilities are very less. More and more students will be towards the mean. More and more students should be towards the mean. Okay, so it means that normally all our social sciences follow normal distribution. All our social sciences follow normal distributions, like height, weight. This follow the normal distribution, and the variable which follows the normal distribution. Okay, first of all, which variable follows the normal distribution? All ratios and interval follow the norm, are can follow the normal distribution. If they follow the normal distribution, then we use the parametric test, and if they don't follow the normal distribution, then we use the non-parametric test. Okay, now, what are outliers? Outliers are those erratic observations which are beyond plus or minus 2 sigma. You can say they are very naughty students in the naughty students in your class, and they are beyond plus or minus 2 sigma. Now, what do I mean by outliers, and why I have taken this particular term here, outliers? Because we will have to identify the outliers, and we will have to the outliers of the residuals have to be considered. Okay, now what are outliers? Let's try to understand. I am trying to collect the income of the respondents. Okay, and in my survey I collected the income of the respondents. So I asked to the first respondent that what is your income. Listen to me very carefully. He understood the question, and he responded the monthly income 5,000. I asked to the second respondent what is your income. He understood that it is a monthly income I am talking about, so he said 7,000. I went to the third person and I asked, what is your income? And he misunderstood, and he wrote the yearly income. And he wrote down 10 lakh. Now all the respondents are writing monthly income, and this particular one person has written yearly income. Now what is happening is, because of the presence of this outlier, see on your screen, the mean will be shifted on this side, or the mean will be shifted on the lower side. And as the mean will get shifted, the skewness will arise in the normal distribution. The curve will become skewed either left side and right side. And if the curve becomes skewed left side and right side, we will not get the normality in the variable. If we don't get the normality in the variable, our distribution is not normal. And if our distribution is not normal, we will not be able to do parametric test. This is the reason, this is the significance of understanding outlier. Okay, so from here we move ahead. So uh, before I make you understand the p value, I want to show you something. Okay, I want to show you something. Wait a minute. Okay, is the screen visible? All of you, is the screen visible?
Yes, sir, it's visible.
Okay, fine. Now, see, I'm trying to make you understand the p-value and what is the interpretation of the p-value and how we will accept the new theory and reject the old theories. So let's try to understand this thing. Okay. Suppose we have given a task to a worker. We have given a task to a worker that you make a 10 mm bolt. Okay. Ravi sir, is it visible now? Jamboard is visible now?
Yes, sir, it's visible.
Okay.
दिख रहा है.
So we have given a task to the worker that please make a 10 mm bolt. Now, what is a possibility that the bolt which is manufactured is of 5 mm? What is the possibility? Okay, the worker is very efficient, a very experienced worker, machines are up to grade. Okay, so what's the probability that 5 mm bolt will be made? Very less possibility. Okay, very less. Okay, what's the possibility that 15 mm bolt will be made? Very less possibility. Okay, what's the possibility that 7 mm will be made? Okay, what's the possibility that 7 mm will be made? Some probability which is higher than 5. What is the probability that it will be made of 13? Some probability which is higher than 15. Okay, what's the probability that it will be made of 9.9? Very high probability because it's near to it. Okay, 9.9, so very high. What's the probability that 10.1? So what I want to say is that what I want to say is that say for example here now suppose if I draw the curve, okay, it is following a normal distribution. Okay, now I want to reject some bolts which are beyond the tolerance limit. Okay, so I want to reject some bolts which are beyond the tolerance limit. So I'm saying that I will draw the fence that beyond this all the bolts will be rejected, and beyond this all the bolts will be rejected. Okay, but how can I draw this tolerance? How can I draw this tolerance? So uh, here I am rejecting the lot. Okay, reject all the bolts which are above this line are to be rejected, and all the bolts which are above this line are to be rejected. Here the fluctuation has happened. There is a fluctuation. Okay, there is a fluctuation, but this fluctuation is in the tolerance zone. Just a minute. Okay, this fluctuation is in the tolerance zone. Now this fluctuation is in the tolerance zone. I'll give you a very simple understanding. Just listen to me very carefully. There is a very naughty child. Okay, so the parents are, you can say, parents can tolerate their mischief to some level. Okay, his mischief can be tolerated to some level. After that his mischief cannot be tolerated. So here the mischief cannot be tolerated. This is the zone, and what we say that the children is out of control here. Listen to me very carefully. Children is out of control here, and here we say processes are out of control. Processes are out of control. Here processes are in control. It means that we are rejecting here, we are rejecting here, we are accepting the lot here. Okay, with this understanding, let's try to come on the PPT. Okay, and I will try to make this thing very simple. Is PPT visible, Ravi sir? Is PPT visible? Is PPT visible, Ravi sir? Hello? Hello?
Yes, sir.
Is PPT visible?
Yes, sir, it's visible. Sir, इसको slide show वो पूरा कर लीजिए. Yes, sir. Yes. Now it's
Now see, with this understanding, with this understanding, let's try to connect the first slide of progressive thinking, the Galileo, the Karl Popper thinking, and all these things now we will connect. Okay, listen to me very carefully. When your p-value is less than 0.05, p-value is the probability value which we interpret, okay, from which we interpret the null or the alternative hypothesis. So p-value less than 0.05, we reject null. Here the fluctuations, so we'll first talk about this. P-value less than 0.05. Wait a minute, there is something in this because of, I can write that thing, no? It's having annotations here. Okay, so here when p-value is more than 0.05, we fail to reject null. Fluctuations due to chance, old beliefs are true, nothing has changed. Okay, try to recall that the child is mischief, it is in the tolerable zone. Okay, the parents are saying the parents are tolerating the mischief, the processes are in control. The fluctuation, the slight fluctuations which are happening, it may be because of the power fluctuations in the machine or something like that. Okay, so here we write fail to reject null. We are not writing except. I will make you understand why. Bear with me. So here we are accepting the lot, which means that we fail to reject or accept, it is one and the same. But in the paper or in the thesis, we write fail to reject. Okay, here when p-value is less than 0.05, we reject null. Fluctuations are due to the assignable cause. New theories are true. Something has changed. Here also something has changed. So new theories. As a researcher, you are always looking for p-value less than 0.05. Okay, p-value less than 0.05, because if p-value is less than 0.05, you are having an opportunity to show to your guide or to the world that I have came out with something new. But don't have that affinity, that always you should get p-value less than 0.05. Consuming coffee has an effect on sleep hours is also a research. Consuming a coffee has no effect on sleep hours is also research. Okay, Thomas Alva Edison has given 10,000 ways in which the bulb cannot be created. He was here, he did not got any result. Okay, so don't have any affinity that p-value is not coming, therefore my research is not there. No, don't think that way. Okay, so why we say fail to reject and why we are not saying accept? Take the same court case. If a person is guilty, okay, if a person is not guilty and the evidences are provided, are given to prove him guilty, but not guilty does not mean that the person is honest, because whatever verdict which is given in the court, it is because it is based on the evidence. We are proving the person guilty or not guilty based on the evidences. If the enough evidences are not there, we cannot prove him guilty. So in that scenario, what can happen? The judge can give you another date in which he will ask the concerned lawyer to bring more evidences. Similarly, possibly you may have not got any result in this sample. You may increase the sample and you may get that different result. And that's the reason we are writing reject or fail to reject. We are never writing accept. Okay, so now I'll switch from this basics to the regression analysis, the concept of regression analysis. Okay, I'll switch to the regression analysis. I hope uh, uh, is correlation analysis is visible on your screen? Is it visible?
Yes, sir.
Correlation.
Yes, sir. It's visible. Visible.
Okay. Now, in any research, it is necessary that you first run correlation analysis between the variable to understand that is it following some relationship or not. Make sure correlation analysis you can run only from scale to scale variable. Scale to scale variable means ratio and interval, height and weight. You cannot run correlation analysis between nominal and scale variable, ordinal and scale variable. Nominal and ordinal you cannot run it. You can only run from continuous to continuous, ratio to interval, interval to ratio. Remember, this is the bottom line of regression analysis. Okay, so all of you are having a data set. I have already sent the data set which is there, employee data. How to open that data? All of you go in file, open data, all of you. Okay, all of you. Ravi sir, can they unmute their mic? Or
Yeah, sir, I will make them unmute if somebody wants to ask something.
yeah, you can ask your questions.
Yes, yeah. Please, participants, if you want to ask something.
Feel participants, you can ask the questions if you want. Okay, otherwise keep your questions reserved for the fag end. Okay, if you face any difficulty in software, feel free to discuss. Now there is a question which has been already be there, that sir, I am using SPSS, a trial version. See, we cannot give anything from here as a crack. Don't think that this, because this is an official thing which we are running, but there is a PSPP. PSPP is considered to be, you can say, it is in the open source community, and it is having a same clone of SPSS, and you can start using that. It's completely free and it will remain free for the lifetime. Okay, so you can start using this. So your file, open data, and please open the employee data which is there, which I have already given to you. Okay, open the employee data. So it will look something like this. Is it there? Okay, so now I want to run the correlation analysis, that how these two variables are correlated with each other. Okay, what's a correlationship between them? So what will be the null hypothesis? My null hypothesis will be, now listen to me very carefully, there is no relationship between X and Y. All swans are not white. Okay, and I will give them evidences. See, learning a SPSS is just a 5 minutes task, but understanding the philosophy of a research takes a lot of time. That why I am doing these things. I can teach you regression in 5 minutes, but what I want you understand the basics, that why we are doing this thing. Okay, because you will have to write the paper, and if you don't understand this thing from the concept, that what I have to write, you will get confused. So we will start connecting that from the first hypothesis, running the data analysis and its interpretation. Okay, and its interpretation. So I want to say that there is no relationship between the current salary and the salary begin. Okay, there is no relationship between the beginning salary of an employee and the current salary. Okay, so how will I do? How will I run? I will run the correlation from analyze, correlate, bivariate. Please, all of you go there and run it. Now you select two variables, current salary. There is somebody is asking a question. Chat. Yeah, I am. Data already Ravi sir has sent the data, employee data. Just see on your screen.
Yes, I have sent to all the mail IDs. Please check your mail IDs, please, participants. And if not received, you can message your mail ID in the group. I will send it just now.
Okay. Now, don't get worried about that. I am not able to run the SPSS. Don't worry. Okay. You are getting a recording. You are getting the example also. Listen to the lecture very carefully. Okay. You'll be able to run all these things. You'll be given ample amount of time. You'll be given the recording. You'll be given the data file. Everything will be given. Just understand how this lecture is going. Okay. Now what I'm doing is I'm transferring my current salary and beginning salary into the correlations, and I'm running the correlation. Now see, this is a p-value. Okay, the p-value. I forgot to share one more thing. Just a minute. I forgot to share one more thing with you. Please, all of you, write down this thumb rule. All of you, write down this thumb rule. This is a thumb rule which will be applicable for next 5 days. A rule of thumb is, if p-value is less than 0.05, please, all of you, write down. Okay. Please, all of you, write down somewhere. Okay. If a p-value is less than 0.05, we reject null hypothesis. P-value is a probability value. And if the p-value is more than 0.05, we fail to reject, or in other words, we accept the null hypothesis. Okay, we accept the null hypothesis. Please write down, take the screenshot. Please write down, because the interpretation is necessary. Okay. Okay, so most of you must have got this result. Now see, this is SIG is a p-value. Okay, SIG is a p-value. This is a p-value. It is 0.000. Now 0.00 does not mean that there is no result. It is the most significant result. Now how? Let's try to understand. This p-value is less than 0.05. It means that we reject the null hypothesis that there is no relationship. I again start with the first thing. From where we started, our null hypothesis is there is no relationship between beginning salary and the current salary. Null. The alternative hypothesis is there is a relationship between beginning salary and the current salary. The rule of thumb is this p-value. Okay, this p-value. So here the p-value is less than 0.05, not 0.5, 0.05. So as the p-value is less than 0.05, we reject null. It means that there is a relationship between current salary and the beginning salary. So that's a good thing. Now as a relationship is there, we can model it. Okay, we can create the model. Okay, we can create the model from here, and as we can create the model here, we go into the environment of regression analysis. What's a regression analysis? In regression analysis, in correlation, we were writing there is no relationship between x and y, but in case of regression, we are saying that there is no significant effect, there is no significant impact, there is no significant influence. All these words convey the same meaning. I am repeating. There is no significant effect, there is no significant impact, there is no significant influence of x on y. And when, as soon as I frame such type of hypothesis, I it is very clear that I am going to do regression analysis. I have seen in many theses that a person is writing there is no significant impact of x and y, and he is conducting t-test. No, that's completely wrong. T-tests are specifically dedicated for the difference. There, as soon as you write there is no significant association, I will show you the summary. Okay, I will show you the summary that what hypotheses are to be written for which type of test. Okay, so you can see the example which is there on your screen. There are some town A, B, C, D, E, F, G. Some towns are there, the population is there, and TV sets demand is there. I want to make an equation in which I want to make an equation in which that is there any relationship between the demand of the TV sets and the population of the town. So in that scenario, I'm using the regression. There is a question which is coming up. Just a minute. What is the question? Not audible. Am I not audible? Hello.
No, sir, you are audible. It's from his side. I've already written. You are audible, sir. No problem.
Okay. Okay. Fine. So dependent and independent variable is there. We will not be using the equations very you can say bombardistic equations. Keep this equation reserved at this moment of time. We will come back here to understand this equation, but let's try to understand this regression by using some memes which I have made. Okay, so I want there is a phenomena of measuring the blood pressure, that you can measure the blood pressure of a patient by using a spigomanometer. Okay, spigomanometer. And I have made some equation to this, that there is no necessity that okay, I have made an equation that there is no necessity to measure the blood pressure using the instrument. You just give me your age and you just give me your weight, I'll tell your blood pressure. So instead of the instrument, I'm using the equation. Do you think that both this thing will tally? No, it will not tally. It will never tally. It will never tally, because there will always be some error. Now this error is a devil in our equation. Okay, and you cannot avoid this devil. The nature has not given equation to any phenomena. They are humans who are giving the equation to the phenomena. For example, we are making an equations for global warming, we are making an equations for pollutions, we are making an equations for deforestation, so for rainfall, for so humans are giving equation to the natural phenomena. And we have seen that most of the time we may go wrong. There is an error, that the forecasting department told that it will rain. There was a forecasting that it will rain and it is not rain. Believe me friends, that when you will go ahead and you will try to understand that how complex these equations are, you will be able to understand the task of our forecasting department, that they are working on so many variables, and it is possible that they can go wrong. It is possible, and you will see that thing live today, that you can also go wrong. So that's a devil. So the difference between the actual and the predicted, I'm repeating again, AP. Remember, the difference between actual and predicted, AP, is an error. The error is bound to happen. You cannot make any equation which is 100%, which is having no error. Now why this thing is there, that the error is always there, is the reasons are, there are many reasons to it. Okay, I'll give the reasons to it also, but let's see what we are doing in regression. Now this is actual blood pressure which is there. This is x and y, this is x and y. Okay, this is x and y, and this is actual blood pressure, this one, this one. Okay, actual blood pressure are all purple dots, and the blue line which I am passing, covering the maximum purple dots, is an error. Okay, the same thing I have represented on the chart. Now what I am trying to do in regression, I want to pass a line in such a way that there is a less and less error between the purple dots. Okay, so initially statisticians had that philosophy that you pass a line in such a way that the summation of all this error is zero. But then the statistician came out with the concept that don't do that way, don't do that way, don't do that way. You pass a line in such a way that, listen to me, that the square of the error is minimum. Okay, and from that day the regression line is also known as ordinary least square method. Ordinary least square method. So with this understanding, let's go back here. Okay, let's go back here. This is something which is constant. This is something which is constant. Okay, so you cannot have a blood pressure 0. You start with some constant of 80 and 120, and that's a constant from which the blood pressure starts. This is the effect of the variable on y. So weight and its effect. So how many times, if the weight is if a particular weight and its effect. Now, what do I mean by this thing is that the increase in the age by 1 year increases the blood pressure by 1.1 unit. Increase in weight by 1 kilogram can increase the blood pressure. This is not a celebrated equation. I have just given you a layman example. Okay, so that can induce the blood pressure. Okay, so why the error is there? Why we cannot make any model which is foolproof, that is 100% foolproof? Okay, which is 100% foolproof. The reason is that there are some variables which are very high. The certainty is high. Awareness is known. Availability, they are available. Measurement accuracy is very high. Remarks, they are excellent. Age. Now, age you measure here or in any other country, it is going to remain same at this moment of the time. Okay, it does not depend on what method you are calculating the age will remain same. Certainty, there is a second category of the variables are moderate, known, available, depends on how it is measured. Remarks, good. The example is income, consumption. Now error starts creeping here. Error starts creeping. What do I mean by why error starts creeping here? If I am asking someone that what is your income, so am I talking about monthly income, annual income, family income, disposable income, taxable income? So now the ambiguity has started. Similarly, consumption. The third category of the variables are moderate, known, unavailable, depends on research instrument, average. The example is opinion, opinions, attitudes, and beliefs. Things can change. The fourth category of the variables are low. Awareness is known, availability unavailable, measurement accuracy cannot be measured, remarks weak. The example is religion and culture. I am saying religion and culture in terms of, can I measure religion and culture? No, I cannot measure religion and culture, and that's the reason I am saying I have kept in the category of weak. Weak in the sense I cannot measure it. Okay, I am saying that I am following the Western lifestyle, but what is Western lifestyle? I cannot define it. Okay. The last category of the variable is the certainty is low, awareness is unknown, availability unavailable, cannot be measured, remarks worst. Genes and hormones, you all have passed through a recent pandemic in which there are ample examples in which a lady of a lady of 105 years old survived the corona. A 6-year baby survived the corona, but a healthy person of 30 or 35 or 40 was not able to survive. So there are no explanations. And yeah, and when there are no explanations, we give that it may be the immunity power or it may be his genetic, his genes may be strong, and all that reasons we are trying to give. So here the chances of error are very high here. So here we are saying observed and expected failure. That is a deviation. Okay, fine. The deviation is there. This also we have discussed. This also. Okay. So we are always trying to study the positive linear relationship. This is negative relationship. This is no relationship. And this relationship is not linear. Okay. If the error is there, if the devil is there, you cannot avoid the devil. But we should ensure that the devil should not increase or decrease. The devil should not have a relationship among themselves, and there should not be a relationship among independent variables. Okay, now why error should not increase or decrease? When error is increasing or decreasing, it's known as a case of heteroskedasticity. All those who are working in the field of econometrics, they know that there are four types of errors, that is heteroskedasticity, autocorrelation, and multicollinearity, which they have to face a lot of problem. Now, what is a heteroskedasticity? The increasing or a decreasing error. The layman example, that when you start driving your vehicle for the first time, okay, you drive your two-wheeler or the four-wheeler, you make many mistakes, but eventually But eventually what happens is that you learn the driving and your mistakes reduces. Similarly, the typographic error which is happening on your keyboard, you commit a lot of mistakes when you start typing for the first time. But subsequently what happens that it subsides and your error starts decreasing. So this is a very clear cut example of the decreasing error. Now you'll be wondering that why is a decreasing error is not good. The decreasing error is not good. It means that, for example, what I am trying to say is what it is a heteroskedasticity. Listen to me very carefully. Okay. Now, for example, there are some participants, and I will name the participants here. Somebody has not written the name. Say, for example, I am taking the Ankit Verma, first participant in your group. I am measuring his blood pressure through the spigonmanometer and through equation, and I have taken the difference. Then I take the Anup M, his spigonmanometer and the difference. Then Arun Mondal, then Asa Bauri, and that way. So initially the error is less and then the error is more, or initially the error is more and then it is less. Both the scenarios are completely, you can say, are not at all, you cannot entertain both the scenarios. Increasing or decreasing error is not allowed. Okay. Why it's not working? Okay. So increasing or decreasing error not allowed. You cannot have a relationship between the two errors. If there is a relationship, it is known as an autocorrelation. Your independent variables should not be correlated. In my equation, say for example, in my equation, I have taken age and weight, and I also consider the BMI. Okay, I am also considering the BMI. Now BMI has got a very high correlation with the weight. Now, in this scenario, what will happen, as BMI and weight are highly correlated, you will get a very spurious regression, and then you will face a problem, and that is known as a multicollinearity. How to detect the multicollinearity, that also we will see. Okay, now what should be the pattern of the error? What should be the pattern of the error? You know, Ravi sir, is it visible? Ravi sir, is it visible?
Yes, sir, it's visible, sir. Visible.
Okay. So the error is there, the model is there, the variable is there. Okay. Say for example, the error is kite. Okay. And the model is the model which I have made of the blood pressure. Now, if your error is showing any pattern, all of you know that if you fly a kite and if the boy is pulling the string, the kite will follow the path guided by the boy. Okay. So if the error is following a pattern, it means that there is a variable in the model because of which the error is showing some pattern. Okay. Error should not show any pattern. So what do I mean by that thing? What do I mean? Cut the string. Now, if I cut the string, the kite would be having a very free flow. It would be flowing very free flow. Okay, plus minus. You all must have seen how if the kite is untied, or if the kite is flying without the string, then it is having a plus minus direction. It will go plus minus plus minus. So your error should be having that type of pattern. In other words, you all have came across the ECG, the cardiogram, in which the the heart fluctuates. Okay. Now, what is the peculiarity of this is that it is a mean returning series. Okay. The heartbeats come to the zero, again pump, again it comes to zero. So your error should not be having any extreme. It should revert back to zero. Okay, it should revert back to zero. It should be having a constant pattern, in the sense that it should be nearer to zero. It should be nearer to zero, and there should not be too much fluctuation from the zero. So here I have shown you the graph of the error. So here, this is not advisable, this is not advisable, this is not advisable, this is not advisable. What is advisable? This is advisable. The healthy residual graph in which we don't have any pattern in the graph of the error. Okay, now how we test the regression, how we are testing the regression model. Before we understand all these things, let's try to understand this thing by using a cartoon which is there. I have not downloaded anything from anywhere. This is my understanding to make you explain the statistics with fun and learn. Okay. So just assume that the lady is a dependent variable. There is a tug of war which is happening. There is a tug of war which is happening, and these are all independent variables which are trying to uh, pull the rope. Okay. Now the glaring thing which is there is that this is the person which is not at all pulling the rope, and it is not contributing in pulling the string. So in our regression equation, this is a dependent variable. These are all independent variable. So is this person able to pull the string? Is this person able to pull the string? We are testing with the help of independent variable t-test. Individually, we are using t-test. Individually, for each and every person, we are using t-test. Okay. And here, this person is totally insignificant. He is not at all pulling the string. He is just acting. He is just like a person in your organization who is just showing that I'm doing a lot of work, but he is not doing anything. So it's an insignificant variable, and any such variable which is there in your equation has to be thrown off. Okay. So a variable is contributing or not contributing. We are testing with the help of t-test. Once the variable, the model has been created, we also see that okay, there are so many variables which are there, 1 2 3, but collectively, can they win the race? Collectively, can they win the race or not? Collectively. So that is the winning part is decided by ANOVA. You may have 100 variables here, which are you can say which are significantly generating lot of pressure, but they are not able to pull the dependent variable. They are not able to influence so much that the dependent variable becomes that there is enough impact on dependent variable. So we will win or we will not win is tested by using the ANOVA, and all this thing comes from p-value. Now again, I will give you another example to this how this t-test is working and what is ANOVA, what is the philosophy of the test. In olden times, the people used to borrow from the bank, and the bank used to write the promissory note from this people. Say for example, there are three partners who have borrowed from the bank some amount of money, and bank ensures that they sign the promissory note. So what was written in the promissory note in the olden times, that we promise to pay the sum of money on so and so date. Now, say for example, after 6 months, when the bank goes to collect the money from these people will say that now the partnership does not exist, and as we don't exist, our partnership does not exist, so we are not liable to pay this money to you. So from that day, the bank introduced another clause. Now, the promissory note, how it is written, I oblique we promise to pay. So here also same concept. Understand from the regression, I am contributing means I am able to pull the string. We are able to pull the string. So I is tested, very simple. I is tested with t-test and V is tested with ANOVA. Okay. R square, we also go for something which is known as R square. R square is the explanatory power of the equation. Explanatory power in the sense that in our normal talks also we are using that today this thing will happen 100%. So that's a model which we have developed from our experience. So what I'm saying is that all these independent variables, how much pressure, how much they are able to pull the dependent variable, that is known as R square. The explanatory power of the independent variable on the dependent variable is considered to be the is considered to is if it is more than 70% is considered to be the good thing. It means that the if the explanatory power is more than 70%, it means that the independent variables are able to explain the variation in the dependent variable up to 70%, which is considered to be the good one. Okay. So let's go to understand the hypotheses which are there now. Now, if you understand this thing, for t-test, for ANOVA, what will be the null hypothesis? B1, B2, and B3 all are 0. Or in other words, model does not exist. Model does not exist. All swans are not white. Okay, all swans are not white. What is the alternative? The alternative hypothesis is, in other words, model exists. This is ANOVA. Okay, you don't have to do all this test individually. It will be done by the software on its own. Okay, it will be done by the software on its own. So here V is tested, and uh, t-test, individual regression coefficients are 0. Individual regression coefficients are not 0. That will be tested by using t-test. R square is the explanatory power of the model. Normally, it is said the explanatory power lies between 0 to 100%. But you cannot achieve 100%. You will never be able to achieve the 100%, because 100% means you are God. And God has not given the permission to anybody to take his position. So you can reach nearer to 70% and 80%, and remaining 20% is unexplained variation in the model. Unexplained variance. It means that this variance cannot be explained by using these parameters. So there is a Valentine's view. All of you can see on the screen. This view was given by Valentine. Now see the first category, X and Y. X is not able to explain anything in Y. This is the Y is the independent variable. Y is dependent variable. X is independent variable. This is not able to explain anything in Y. Here it is able to explain something. Here the explanation power has increased. Here it is increased. Here it is increased. But here, this is again the problem of multicollinearity. Y is equal to X. Y is highly correlated with the X. If Y is equal to X, then why a regression equation is necessary? So in such scenario, so F and A are totally not advisable. Okay, if you want to read something more about this, it is given in Damodar Gujarati. Those who follow econometrics, it's a Valentine's view which has been given in Damodar Gujarati. So with this understanding, let's try to run the regression model. The data file I have already given. I'll just take 2 minutes break and I'll come back. All of you open the employee data. Okay, I'm back again. So we'll start now. Let's try to understand that what this employee data is. This is an employee data which is example which is given in your Spss data set. It is there in each and every default data set which is there. I want to find out that what are the factors which are contributing my current salary. Okay, what are the factors which are contributing my current salary? So all of you. just click on the variable view. Just click on your variable view, all of you, and you can see the variables which are there. So here I want to model, I want to make a model that my current salary is depend on what factors. Okay, so I am taking considering the beginning salary, the previous experience, my education, and all that factors are considering, and I'm trying to make the model. So with this, analyze regression linear with this understanding. So transfer the current salary into the dependent list. Okay, all of you transfer the current salary into the dependent list, and transfer education level, beginning salary, months since hired, previous experience, and minority classification. Just a minute. Just a minute. Wait a minute. Wait a minute. Okay. Transfer minority classification also here. Okay. Transfer the minority classification. Am I visible, audible, Ravi sir? Am I audible?
Yes, sir. Yes, sir. Clearly, no problem.
So transfer the current salary. I want to find out that my current salary is affected by what? My current salary is affected by what? So beginning salary, months since hired, previous experience, and minority classification. Please transfer it here. Okay. Please transfer it here. Okay. So transfer it in independent. Click on statistics. Click on statistics. All of you. Click on statistics. All of you. Click on statistics. A window will pop up. A window will pop up. Make it sure that not on Durbin-Watson. Don't click on Durbin-Watson. Click on collinearity diagnostics and model fit. Okay, and model fit and model fit. Click on collinearity diagnostics and click on model fit. Click continue. You all know the thumb rule. The thumb rule is there with you. Keep as a thumb rule as a guiding map for you. So you will get this result. Okay, you will get this result. All of you are at least one person say you got this result or not. Can you unmute Ravi sir? Yeah, you got the result.
Yes, sir. Yes, sir. Yes, sir. They have written done. Got it.
Got it.
In chat box.
Now let's try to understand this thing. Okay. See, there is, you can see the picture in picture view which I have given. This all these four variables are trying to pull the string, but this minority classification is not at all pulling the string. Okay. How I came to this conclusion is it is on the basis of the p-value which is there. Remember the normal distribution, remember the p-value. When your p-value is less than 0.05, these variables we reject null. So here the desirable thing is that your p-value should be less than 0.055. So here all those variables whose p-value was less than 0.05, they are significantly contributing, and those variables whose p-value is more than 0.05, they are not contributing. They are not at all contributing. Okay, all those variables whose p-value is more than 0.05, not 0.05, all those variables whose p-value is more than 0.05, they are not contributing. Now what we should do, we will run the regression again, and we will remove this minority classification from here. Okay, that is later on. This is ANOVA. This is ANOVA means this is a t-test in which I am contributing, and this is we are contributing. So here also the desirable way is the p-value should be less than 0.05. What was the null hypothesis of the ANOVA? Model does not exist. What is the alternative of this? Model exists. So here, as the p-value is less than 0.05, we reject null. It means that model exists. Here, always desirable here or here. The thumb rule is p-value should be less than 0.05. Now here, you see that the R, you should see R square and adjusted R square. Here the R square is 0.811. You multiply by into 100. It means that the model is able to explain 81%. This These independent variables are able to explain the variation in the dependent variable, that is a current salary, up to 81%. That's really great. 19% is error. You can never get this thing as 100, or you can not get here 0.9999, 0.999, because if it is 0.99, either you are God or you have committed a very grave mistake. If you get something here as 0.99, either you are God or you have committed a very grave mistake. The grave mistake can be, there are two variables which are highly correlated. I give you the example of weight and BMI. If the weight and BMI are highly correlated, or if there are any two variables here which are highly correlated, you are bound to get R square inflated, highly inflated R square nearer to 0.999. Now here individually they all will be insignificant. When you get two such variables which are highly correlated, you will find that these are insignificant. This is insignificant, but R square will be very, very high. So make it sure that you don't draw such conclusions. Okay, so there is a question which is coming up. Let me see what's the question. Do we use regression to Likert scale as well as logistic regression? Please convey. I'll come back to you. Please keep questions reserved. GHRC, someone has written. Okay, keep your questions reserved. I will answer each and every query. Okay. So this is not the, okay, now the regression, the minority classification, which was not significantly contributing, now it's time to chop it off, to remove it. So all of you go back again, analyze regression linear, and make it sure that you remove the minority classification from the analysis. Okay, remove that and try to run the regression again. And now you see all the results are bingo, everything is excellent, everything is contributing, all p-values are less than 0.05, 0.05. So here you should get, ideally here your R square should be more than 0.7, and there should not be significant difference between R square and adjusted R square. Now if there is a significant difference between R square and adjusted R square, it means that there are some variables who are there in your model here, they are not contributing. They are just trying to act as they are contributing, and because of which your R square has increased. So when you will remove this, your R square and adjusted R square will be nearer to each other. So now all of you scroll down and you will be getting such equation. Just see, are you getting this equation? In which there will be an unstandardized coefficient and a standardized coefficient. The first thing which you should do now is, the basic thing is known as a sign test. Sign test is not having any formal testing. It is just a visual inspection of, see my cursor. It's just a visual inspection of this thing. See my cursor. It's a visual inspection of this thing. It means that if the education level increases by 1 year, my salary increases by 669. Very good. If my beginning salary increases by 1 rupee, my current salary increases by 1.768. Very good. Months inside, depending upon how many months I have been old, my current salary increases by 161. Very good. The more my previous experience, my salary decreases by 17 rupees. Now that's illogical. How can I? How it can happen that if my previous experience increases, my current salary can drop? So there are many examples to it. That, say for example, you must have seen the packages of all the actors and actresses, that till some age their package increases, or their some remuneration increases, their fee increases, but after that they are having a downfall. Okay. In IT industry also, this type of thing is that as the experience increases, the package might get reduced. So in such scenario, you can have a negative thing. So you can change the signs, but make it sure that whatever signs which you are getting, positive or negative, they are aligned with the existing body of the literature. It means that half of the world is saying that the entire world is saying that the smoking causes cancer, and you have came out with the conclusion that smoking does not cause cancer. You have came out with the new thing. The signs have changed. But before reporting such result, make it sure that your model is not suffering from 4 problems. What can be the 4 problems? The first is model is incomplete. All the variables are not considered. The sample size is too small. It may happen that the sample which you have collected is totally skewed sample, and in such scenario you may get the change in the signs. The functional form of model is incorrect. The pandemic is spreading with the quadratic nature, and I'm trying to study the spread of the pandemic using linear regression. That's not at all advisable. Some variables are highly correlated. In such scenario, you may get the signs which are not aligned with the international researches. Fine. So R square. Now how will I make the model? Okay, how will I make the model? So the model will be made by this way. So my model is the present salary, current salary is equal to minus 16149 plus 669 plus education level, plus 669 into education level plus 1.768 into beginning salary plus 161 into months in hired minus 17.303. This is the regression equation which is being made. Now you must have heard about regression equation at various forums. Normally, we don't go beyond this level, but as you are in the advanced analytics, so you have to move ahead from here. You have created the equation, that's fine, but we expect more thing in advanced analytics. So from here, the second story starts. The second story starts is the analysis of the residuals. Okay, analysis of the residuals, the analysis of the devil. Okay, the devil which was generated. So residual analysis, that how these residuals are they following a normal distribution or not. So this particular part, this we already discussed. Most of the research forums, or most of the SPSS research forums, they discuss this part only, first and second. Now it's time to discuss that about the error. So the residuals should be normally distributed, and it should be mean centered around 0. I have already told, I give you the example of the bolt, 10 bolt. Okay, more and more observations should be nearer to the 0. More and more observations should be towards the 10. Or in other words, if I say on the standardized scale, the ECG which I had talked about, the error, the mean of the error should be 0, and the standard deviation of the error should be 1. So here, suppose the actual value, now try to recall the spigomanometer which I had given. The actual value is 43 and the predicted value is 42. So here the residual is 1. So here the devil is comparatively less. Here the actual value is 43 and the predicted value is 20, and the difference is 23. So the devil is too much. So here the model, this model is not good. This model is good, is a good model. So what do I mean by this thing is that the probability of a very big error, try to recall a very tall boy in a class, very short boy in a class. Similarly here also, probability of a very high positive error, probability of a very high positive error should be very less. Probability of a very high negative error should be very less. More, the error should be nearer, more and more error should be nearer to 0, mean should be near 0, and the standard deviation should be 1. Okay, so with this we will try to analyze the residuals of our today's model. Again, go in analyze, click regression linear. You have already done this thing, and this thing will be active. Your model is active. Click save, open save, open save, open save, and here you should click on unstandardized and standardized, unstandardized and standardized residuals. Okay, click on it and I will show you what will happen. Okay, this we are not analyzing, I'm just trying to show you what residual has generated for us. Click on it, unstandardized, standardized, unstandardized, residuals also unstandardized. Click continue, click OK, and come to the data view. It will be here just at the bottom. You open the SPSS file because output file will be generated. You don't go in output file, you go in data view. And in data view, a new variable has been generated. And that variable name is resi1. 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 So this was the actual blood pressure, the current salary. This is the predicted blood pressure, the model given by the model. So this is current salary is 57,000. According to the model, it should be 5490. The difference between them two is the residual 2019. We are trying to do the analysis of this part. Okay, we are trying to do the analysis of this part. This is known as residual. Okay, this is predicted, this is residual. Okay, so there are some assumptions of the on which the model is good or bad. We are trying to evaluate it. There should be the linearity. The relationship between the predictor and the outcome variable should be linear. Big deal if violated. If this is violated, it means that the model is not running perfectly. Homoscedasticity, I give you the example that the error should not be increasing or decreasing. The error variance should be constant. Normality, this is a normality which I have already talked. The chances, the probability of a very large error should be very less. The probability of a very small error should be very less. If you don't recall, I will give you an example to this thing, that the probability of a very strong positive error here only, I will come back here only, that I have measured the blood pressure of the first participant using the spigonanometer and the equation. The positive, very high positive error should be very less. Very high negative error should be very less. The error should be nearer to 0 and the standard deviation should be 1. So we are trying to understand the residual, and if the residual analysis is perfect, then only you should report the regression. Most of the time we don't report the residuals and we just give the regression analysis, and we worry that why our paper is not accepted. Okay, so with this, let's try to analyze the non-linearity in our testing. The non-linearity, that is are my variables following the linearity, that is the relationship between x and y, linear or not linear. So all of you go and analyze regression linear. This is default. We have done this thing many times. So a window will pop up, and in window, click on plots. Click on plots. Okay, click on plots. So transfer z predicted. Transfer z predicted to x, and transfer z residual. The standardization of the residual to y, and the predicted z predicted. The standardization of the x, standardization of the uh, predicted variable, that is a current salary, into the x. Click on continue, and you will get this type of relationship. Okay, now you can see how to understand this thing is that more and more points are nearer to 0, which is very good. Okay, which is very good, which is really excellent. But still we cannot say anything from this. So what I say is double click on this. Okay, double click on this, and a window will pop up. I am again repeating, double click on this, a window will pop up. Okay, such window will pop up. Okay, I am again repeating, here, click here or here, double click on it, a window will pop up. And when a window will pop up, click on elements, fit line at total, fit line at total, and you will get this type of line. If the okay, you will get again a window in just you click Loess curve. Click on Loess curve. Click on Loess, apply. Okay, anybody who has lost the track? Okay, all of you are on the tracks. So if you get the straight line here, it means that, or if your line is nearer to 0, it means that the linearity is maintained, and it is a very good sign. Okay, it is a very good sign. Here more or less your line is nearer to 0. You will never get a perfect straight line, as it is nearer to 0, and you can say that things are working quite smooth, and the model which you have created is a good model. Then we say the homogeneity test. The homogeneity test is, you can see the fluctuation of the residual which has happened. See the devil is very less here, very less devils here, also very less devils. More and more devils are towards the zero, and therefore you can say that the homoscedasticity is there in the variance, and that's homoscedasticity is there in the residual, which is a very, very good sign. Okay, now again move back, move to the plots. Again click on plots. So from where you will go, analyze, regression, click on plots, and just click on histogram and normal probability plots. Histogram and normal probability plots. Just bear with me. Now it is only 4 to 5 minutes, not more than that. Okay, click on histogram and normal probability plot, and you will get this type of statistics. Now the point which is noteworthy is, see the standard residual value. The standard residual value is nearer to zero, very nice, which our goal has been achieved. And the standard deviation is near to one, excellent. Okay, is nearer to one, which is also considered to be the excellent. What are more positive stories for us? The more positive stories are, you see in output window, you can see that the normal distribution is followed by the residuals. The devils are less towards this fag, and the probability of committing very large positive error is less, and positive of committing probability of committing very large negative error is also very less, and is following a normal distribution, and this is really nice. Most of the time in we have been asked the question that, do regression analysis require normal distribution or not? No, regression analysis does not require normal distribution, but the errors which have been generated, the residuals which have been generated by the model, it should follow the normal distribution. Okay, so then there is a normal QQ plot. This normal QQ plot is just an extension of the normal probability plot. If you get the good normal distribution plot, you will never by default get the good quantile plot. Now what is this thing is, this is ideal situation. The center one is the ideal situation. This is worst situation. The third, the right end, this is the worst situation. More and more points should be on the straight line, and if they are on the straight line, you can say that they can say that the outliers are less. These are all outliers. I hope you remember the outliers, the naughty child in your class. Okay, if there are more out, see, these are all outliers. It means that the model is not at all, your data is not at all following the model, and the model is completely weird, or a spurious regression is there. So this is idealistic situation. Even if you get this type of chart, it's, you are happy. So let's see what type of chart you have got. Okay, so it's more or less nearer to zero, and you can say that the model is a good model. Yeah, there is no harsh deviation from the model. Okay, so that's interpretation of the QQ plot. The last part, which is a multicollinearity, which is there, which I have talked about, that if your variable is, if your model is considering, if is having a BMI and weight, so in that scenario you don't have to do anything. Just see the tolerance and VIF figure. Tolerance and VIF figure, just scroll in the output window and just see there. So your tolerance should not go below 0.1, and the VIF should not go above 10. Okay, tolerance, if it goes below 0.1, it means that there is a multicollinearity. It means that there are two variables which are highly correlated. Tolerance figure of any variable should not go below 0.1. Actually they both are inverse of each other. They are both inverse of each other. See, you take the inverse of one tolerance, 0.516, you will get VIF. So the tolerance should not go below 0.1, and VIF should not go above 10. Any variable whose tolerance goes below 0.1 and VIF goes above 10, it means that that variable is having a multicollinearity with some another variable. So thank you. This is a regression analysis with the residual analysis. The question I hand over to Ravi sir. Ravi sir.
Thank you, sir. If sir, there are some questions in the chat box, so Can we?
Yeah. We will start asking the questions.
Yes, and if
Uh,
somebody wants to ask the question to sir personally, they can click the raise hand icon.
Before that,
Okay.
see, these are the books which are available of me on the Amazon. Statistical Analysis using R software. This is coming up with the new ebook version, which is having all multivariate data analysis using R. This is machine learning with R rattle. These are all basic research methodology. This is with Minitab. We are teaching, that is our team, myself and HITESH PARMAR sir have created a team of 2 people. Okay. And we are teaching all the softwares which are related to econometrics, time series, machine learning. We teach Python, data development analysis, econometrics, all these things, reviews, and all these softwares we are teaching. We have almost completed 90 workshops and have taught more than 4,000 faculties. And this is my contact number, this is my email. You can follow me on Twitter. You can just send me hi on this my mobile number, and there is my group of DM, in which wherever my program is there, you will be getting the notification. So with this, you can join me, and I am always thankful to Ravi sir for giving me the opportunity in their so big INSPIRA platform.
It's our pleasure, sir.
Thank you, Ravi sir, for inviting me. So we will open the
Yes, sir.
house for the question answer.
Sir,
Okay.
first Mohammed Khan, sir. Yes, Mohammed ji, please unmute yourself.
I'll just wait.
Yeah.
Sir,
Khan, sir.
if you want to write in research paper, do we need to put alternative and null hypothesis both, or we just need to have one hypothesis?
Sir, please, I am not able to. Hello.
Yeah, hello. Can you hear me, sir?
Yeah. Please.
In research paper, do we need to have both hypotheses, or we just need to put only one hypothesis?
You have to put only one hypothesis, null hypothesis.
Okay, and in thesis we need to have both, sir. If we are doing PhD dissertation, right?
In thesis, normally we keep both. We keep both the hypothesis. This GHRC is saying that, sir, please unmute me. Ravi sir, I request that please unmute everybody that they can ask the questions. Okay.
Okay, sir. Okay.
So in research paper, we just need to have a null hypothesis, right, sir?
Yeah.
Okay, sir. Thank you.
Hello, sir.
Yeah.
Hello, I'm Dr. Rupam Mukherjee. I am the assistant professor of economics from Kobi Shukanto Mahavidyalaya, West Bengal. Sir, I have a query to ask you that, sir, in case of many research activity, what I have found that in many papers, it has been mentioned that whenever we are going to test the multicollinearity problem that you have right now mentioned, that we will go for the test of VIF and tolerance. But the issue is, in many research papers, I have found that the safe limit of VIF has been mentioned as 2. In some papers, I have found it 5. And today you have mentioned it about 10. So, sir, what is the actual guideline?
See, you will find different thing in different books. If I am also addressing some forum, by chance, at some place I will say 0.2 and 5. The call basically goes on the researcher. Okay. It should not be below 0.5. How much leniency you want to allow. Now, why this discrepancy is there? Let's try to understand. It is next to impossible that when you are taking more than 4 or 5 variables, that you may get tolerance which is less than 0.2 or 0.5. So here we are keeping some leniency that if it is less than 0.1, then we will say that the multicollinearity is there. The more stringent, the more chances that you get the multicollinearity. Okay. So it depends on the researcher, first thing. The second thing, it depends on what type of variables you are addressing. Listen to me, sir. What I'm saying is, now if I say that there are some variables which are related to the weather, okay, which are related to the environment. it is next to impossible that all these variables are not related to each other. They are definitely related to each other, and in that scenario you are bound to have some multicollinearity. So in that scenario, what should be your stand? You have to decide. Okay, so there is nothing wrong. Somebody has said 0.1, somebody is saying 0.2, fine, but ultimately the bottom line is that this is the way a multicollinearity is detected.
Okay. And sir, another question related to it is that in many analysis, in case of multiple regression, suppose sir, I am taking y as the dependent variable, and say x1 and x2 are the two independent variables. But it may so happen that there are some other variables, say x3, that is being impacting both x1 and x2. So sir, what we actually call the endogeneity problem that may arise. So, sir, how to counter it in, and whether there is any rule to counter this in SPSS?
I'm not getting your question. Please repeat.
Sir, suppose in some statistical investigation, I am getting y as the dependent variable, and that is being influenced by two independent variables, x1 and x2. And in that case, sometimes we also get some other variable that is not already included in the model, say x3, but there is a link between x3 and x1 and x3 and x2, and it may so happen the presence of x3 may have triggered the performance of x1 and x2.
Okay.
So the question of endogeneity and how to tackle it in SPSS.
Yeah, I got it. What you want to say is that now x3. Now what x3 can be? So may I know your good name, sir?
My name is Dr. Rupam Mukherjee.
Dr. Rupam, sir, I will give you some explanation, and I am always try to explain the statistics in a very simple way. Okay. See, understand that that x1 is having a love story with y. Are you with me?
Yeah.
X1 is having a love story with y. Now x3, or you can say x2 or x3, what role it can perform? The x3 can work as a villain. First thing.
Yes.
The second thing, it can work as a mediator.
Yes.
The third thing, he can work as a supporting artist.
Yes.
Now all these things have a different way to cater.
Okay.
Suppose if I want to control x3, then I will be using the ANOVA,
okay,
in which I'm controlling the effect of x3.
Okay, sir.
If I want to say that that x1 is able to the success of love story of x1 and y will depend that how much x3 is depending, the mediate, then it is known as a mediation analysis. Okay. And suppose if I say that x1 and x3 collectively will affect y, then it is known as moderation.
Okay.
Now mediation and moderation cannot be done in SPSS directly. For that there is the, you can say, add-on package by Hans, the Professor Hans, which is a macro, you can say process macros. You download process macros and you'll be able to do that type of analysis, in which you can say that how much x3 is mediating, or how due to the presence of x3, how much x1 is influencing y. Okay. Now this is a story if the variables are in a direct scale. Suppose the same thing is that x1, x3 and y are constructs. You cannot do this analysis in SPSS. You will have to directly go into AMOS, okay, in which the constructs are considered. I hope I have answered this question up to your expectation.
Thank you, sir.
Thank you, sir. Thank you. Thank you. Yes, GHRC. Yes.
Sir,
What's
only
your
one,
name, sir? What's your name? First of all.
This is Dr. Dilip Singh from Nagpur,
Okay,
GHRC.
okay.
First of all, I would like to congratulate INSPIRA for organizing such a beautiful session.
Thank you.
And we are blessed to have you as our resource person, sir. Dhaval, sir. Just only one thing, that most of our management research are based on like perception or satisfaction measurement sort of thing. So usually we are using, sir, Likert scale. So please tell me like which statistical test we are using for Likert scale. This is only one question I have, sir. Please.
Now in Likert scale, you can are there demographic variables available?
No, sir. No, sir.
No. What I'm asking is the
Hmm.
questionnaire is there.
Yes, sir.
The questionnaire is there. I understand one thing, that there are questions based on Likert scale,
Yes, sir.
and there are some questions which are based on demographic variable.
Yes, sir. Sometimes it is there.
Okay. Now the first thing is, say for example, gender and Likert scale.
Yes, sir.
Gender and Likert scale, male and female and Likert scale.
Yes,
You
sir.
can use independent sample t-test, or you can use Mann-Whitney u-test.
Okay, sir.
Gender and Likert scale.
Okay, sir.
Now second category,
Okay, sir.
more than two groups.
Yes, sir.
More than two groups, like age 0 to 25, 25 to 40, 40 to 60. More than two groups. Now
Yes, sir.
in such scenario,
Yes, sir.
age and Likert scale, you can use ANOVA in parametric test,
Okay, sir.
or Kruskal-Wallis in non-parametric.
Okay, sir.
Second thing. The third thing is that considering all these Likert scale statements, you can run factor analysis,
Okay, sir.
exploratory factor analysis.
Okay, sir.
If all these statements are based on some model, then you can also run confirmatory factor analysis.
Okay, sir.
Clear?
Yes, sir. Thank you so much, sir. Thank you so much.
Is there any other question?
Yeah, thank you. Daksha ji,
We,
please.
we give lot of guidance to the PhD students. Okay, so you can take down my number. We give lot of guidance. Sir, let me allow to share the screen.
Yes, sir. Yes, sir. No problem.
You can take, all of you can take.
I have also given your number in the WhatsApp group also, sir. And
Okay,
all are
that's
in
fine.
the group. No problem.
Okay, so we give lot of guidance. Okay.
And anybody can ask me the sir's number. I will send the number. Yes,
Okay,
Daksha ma'am, please.
Hanji.
Yes, sir.
Good evening, sir. Sir, actually, I am doing my PhD and I have this very basic doubt. Number one, as you mentioned, कि normality मेरा data का normal है या नहीं, that has nothing to do with regression, right? My residual should be normally distributed. The squares of my residual. Okay.
Daksha ma'am, can you start your video if you don't mind?
Hanji, sure. Yes.
Yeah.
And number two, I was reading somewhere that social science may, I mean, what is the regression ka value, I mean, which is acceptable, as you said, is above 70, right? The impact one variable has on another. But then I was reading somewhere that, because there are certain aspects like spirituality, right? Spiritual intelligence that has a very minute effect on certain things. So even 20 or 30 or 40 is acceptable. Is that correct?
R square?
G.
See, R square, if you get less than point, now why not less than 0.5? Let's try to understand. Explanatory power less than 0.5. Suppose if I toss a coin, Daksha madam, what is the probability that I will get heads or tails? What is the probability?
50.
Okay. Now I am making a model. Listen to me. I am making a model. Listen to me. Okay. A very humorous model it is. That if I toss a coin 8 a.m. in the morning, when the wind is is having a 2 km/h speed, and the humidity is 80%, and the temperature and the pressure is this much, then there are 40% chances that it will be a head. Will you accept this model?
No.
Why?
That has nothing to do with the wind.
No. Will you accept this model? You will not accept it.
Yes.
Because the probability of the nature is 50%. And you are making a model whose explanatory power is less than the nature's probability. So when you can say that your model is working, when you jump above 0.5.
Okay.
Now the question arises that what if R square is low and the individual variable is significant? If the individual variable is significant and if R square is low, nothing to worry. It does not mean that you throw the model. Include some more variables. This is there. This person is going to pull my string. Now you include some more variables who are having more capacity to pull the string.
Okay. Okay.
Clear?
Yes. Thank
Now,
you so
if you
much.
don't have such persons or variables who can pull the string, then you go for moderation. X1 and X2 is there.
Okay.
X1 and X2 independently is there. Now you combine X1 with X2, multiply X1 with X2,
Achha.
and you can increase your R square.
Okay. Okay. Thank you, sir. And there's one more, this basic doubt I was getting that, say, for example, I have n number of statements measuring spiritual intelligence. So I have some 20 statements which are measuring spiritual intelligence. And then I have some 20 statements which are measuring job satisfaction. And what I'm trying to do is I'm trying to find the impact of the spiritual intelligence, or maybe the organizational workplace spirituality, as we say, the impact of this on the job satisfaction of the person. So what do we take? The total value of all these statements or the average of the value of these statements? I mean, while finding out
both this method was prevalent 30 years back.
Okay. What do we do?
No, it is nothing to worry. You will get the PhD, nothing to worry. Okay, I'm giving you a way, ma'am. Okay. Now, what we used to do is, we used to do the total of it, take the standardized, and we used to regress one on another.
Yes.
If there are only two constructs, then things are very simple.
Okay.
You can do it. Okay, take the total, take the standardized value of spirituality, take the standardized value of another variable,
yes.
Run the regression, things are over. But if there are more than 2 or 3 constructs, you will have to understand structural equation modeling using AMOS, in which you take many constructs together and you try to understand this thing.
Okay.
Okay.
Okay. Thank you so much, sir.
Okay.
Thank you, sir. Okay, yeah, Darshini ji, please.
Yes, sir. So, sir, again, I'm a research scholar, and my question is really basic question. So, sir, you talked about correlation. We first correlated two variables, the current salary and the beginner's salary. So, and we found that they both the variables were highly correlated. So, sir, still we perform the regression. So, in between your lecture, I heard something like, if the variables are highly correlated, there's no point of performing regression, something like that. So I couldn't understand that part.
If variables are
highly correlated, then there would be some problem in regression. I understood something like that.
Oh yeah, no, very nice. You heard it perfectly. See, you want a correlationship between X and Y. Is it clear?
Yes, sir.
But you don't want a correlationship between X1 and X2.
Okay. Okay.
So I hope I am clear.
X are independent variables.
You want a correlationship between dependent and independent variable, but you don't want a correlationship between two independent variables. If there is a high correlationship between two independent variables, it is known as multicollinearity.
I got it. But sir, we checked correlation between one dependent variable, which was our current salary, and one independent variable. But there were other independent variables also. So we need to check one by one for all of them, or we need to do from that VIF the last thing.
No, you can run multiple correlations from there. You can run multiple correlations from there. Okay.
So we need to do multiple correlation of all the variables.
Yeah, multiple correlations.
Okay, sir. Got it.
Okay. Is there anything else? Any question?
It was a wonderful session, and I got everything. Thank you so much, sir.
Thank you. Thank you. You can follow me. You can just send me hi on my number, and you can send any feedback on if we can improve. Feel free to discuss anything if you like, so that we can. If you want to change in the pedagogy, feel free to discuss. Anybody? Any questions? Any questions more, Ravi sir?
Yeah. Any questions? Okay, Khan Saab. Yes, Khan Saab, please. You can ask. Please unmute. Khan Saab, unmute yourself.
How can we improve our statistics? I'm not quite good in statistics. When I attended a few workshops, is there any books basic book that we can read and improve our statistic part?
Sir, I always tell that first read Ken Black. Okay, read Ken Black, the basic statistics, business statistics, Ken Black. It will improve your statistics like anything. Read good books. That's the only thing. I can recommend. On the last day, I will give you the chronology in which, and the order in which you have to read the books. I will send the chronology to Ravi sir. Khan sir, you just write down that you have to collect the chronology from me. I will be sending you the chronology, that these are the good books which we have read. And it is not, you can say, it is not, the Rome was not built in one day. We have taken 12 years to come here. Before 12 years, we were just, you can say, like a normal scholars, but we made a point that whatever difficulty which we had faced during our research, we should not, now the new generation should not face, because at that time SPSS was completely new. So we created a team, and we are keeping everything open. There is nothing monopoly which we have created. You go in any of the YouTube channel, if they are sharing anything like this, please tell me. They will not share anything with you or any books with you. We have connected each and every dot from hypothesis to the conclusion. So attend some good sessions, read some good books. That is the only solution. One more thing I always say in all the research forums, that suppose if I give you the video of doing a dental surgery, that do this dental surgery, see the video of this dental surgery, how they are performing, and you see the video for 365 days, will you be able to perform the dental surgery on the 366th day? No, you will not be able to perform. You will have to practice. Take a data set, take the data set of your scholars, take a data set of your colleagues, start practicing in it. And if you start practicing, you will face a problem. And if you face a problem, from that moment of time a research will start.
Okay, sir. Thank you so much.
Thank you, Khan sir. Anybody else? Okay,
Anybody
so
else
already
wants to?
I think everyone is so happy. It's already 7:50 already, sir. Thank you so much for the wonderful session, sir.
Thank you.
And tomorrow, participants, we will meet again on the topic exploratory factor analysis, which will be taken by Professor Hitesh Parmar, sir. Thank you, sir. Thank you.